Now remember, these are part of my first line of defense. My skin and my mucous membranes. These eosinophils, well, one of the things that they're known for is to fight parasites like worms. Yeah, people get worms. Okay. Now, the other flip side to eosinophils, they are very good at working against allergens, which right now are in high amount, but they're pretty much in high amount all the time, believe it or not, just different types, okay? And it depends on which ones you have a specific allergy to. And they will use their quote-unquote superpowers with the other against all these pathogens that will try to invade through the skin and mucous membranes, the first line of defense. So they are very important all the time because of everything trying to invade us. Basophils. They're going to have secretions that they can give off. They help my leukocytes, my cells through here, because their job, get to the area of the breach. What do I mean by that? A wound. So if you have anything that will break the skin or those mucous membranes, basophils want to get to that area. Now note, they're not simply just wandering around, okay? They are waiting to be able to get to the breach. Their secretions that they give off act as a vasodilator. Dilate the vessels. What vessels? The blood vessels. Why? Sort of. Do what?
To bring them to the room.
To bring what?
To bring the different cells to the room.
Because I've had a breach. This means I have cut the vessels in some way. Meaning, whether that's a small vessel, such as my capillaries, or the smaller ones, even getting to the larger ones, like if something has, you know, perforated through like my femoral artery or something. But the goal, all of those chemicals that are in the blood, for example, platelets, other white cells, any type of these chemicals that can start, the fibers, that fibrinogen, okay, I want to make sure that it can get to the point of the breach. If I have the vessels at that area dilate, more blood is rushing in, and therefore bringing more of these chemicals that can help. These cells, anything that can help with the breach. In connective tissue, and remember, around our vessels, the blood vessels, we have connective tissue, and a cell that's there is termed a mast cell, and they're very good at helping fight anything that's trying to invade by way of that breach. Lymphocytes. Now, do you happen to remember when we were in chapter 18 and the colonies that got formed? I had this really huge colony just for monocytes and lymphocytes. Do you remember that? Because I end up with granulocytes and agranulocytes. Lymphocytes. When we look at them under the scopes, they can look similar, but we place them into three categories. We have natural killer cells, and just like their term implies, in a non-specific defense, they act like a killer cell going after a pathogen. And we term them natural killer cells. But another way that you will hear these referred to are for cancer. Because these are really good at helping fight cancerous cells in the hopes that the cancer won't develop. All right, so it's another way that you'll hear of them. Our T cells. Remember those. Why are they called T cells? Thymus gland. They were formed in the bone marrow. They migrated to the thymus gland. They are exposed to that hormone, and they develop into the T cells. Where do they go after they have been exposed to the thymopoietin? Lymph nodes. B cells. Do you know why they're called B cells? Well, first of all, T cells. Are T cells going to be something that are going to constantly be produced in a huge amount by the body? No, because they're going to get formed early in life. Because what happens to the thymus gland as from the time we're born? It gets smaller. Now, B cells. Do you know why they're called B cells?
They form in the bone.
Because they're formed in the bone as we need them, as we call them up. Okay? But where can they go and kind of sit and wait to be called up for action? Do you know where at on that lymph node? Because the T cells were inside the lymph node. But do you happen to remember us talking about where the B cells are? If you think about that lymph node, do you remember us talking about little dips on the outside of the lymph node? On the lymph node? Should be in your notes. If you go back to our structure, germinal centers. And then if we look at that, do you guys remember us talking about how if those B cells need to multiply, that's the reason your lymph nodes swell up? Okay, it's because they are they're actually allowing for the B cells to duplicate. So, all of this is available to us in this non-specific, where no matter what we may get exposed to, all right, we're going to see that these cells are working in the same way. Now, our monocytes, when we have a lymphocyte that will move from the blood into the connective tissue, what it wants to do is turn into that macrophage. And it simply wants to wander around. Some are fixed, depending on the area of the body, and they want to wander around and eat the foreign cells. Now, these proteins. Do you remember in the video, the little piece looked like a tooth, okay? Then the great big huge cell, okay? And then you saw those proteins come together and then perforate that cell's membrane, all right? These proteins, the one that was shown in the video was called the complement, LE, okay? Another type that we have are interferons. Have you ever heard of those? An interferon. How might you've heard of them? But have you ever heard of this, say, maybe someone whose child stays sick a lot, they may have to go get an infusion, okay? They could be getting an infusion of these proteins because their body could be lacking in this, and therefore their body lacks the ability to have a complete immune system, okay? So these proteins, antimicrobial, so they want to work against microbes, what we consider to be pathogens and foreign substances in the body. Their goal, inhibit microbe reproduction. Stop whatever that pathogen is from reproducing. However, what we end up getting is short term. This is not a long-term answer to the problem. Under normal conditions, this is great, okay? Because, like I said, every day we are exposed to something, okay? So, under normal conditions, this is great because we have bacteria that are trying to invade us. We have viruses that are trying to invade us. Every time you touch something, your chances of encountering a bacteria or a virus are great. Have you ever thought about what exists in a bathroom? Have you ever thought about that as you go in there and people might be in there and they don't wash their hands when they're done? And then they go open the door that you've got to go touch to get out. Do you think of it on the door handles of just a regular room? Do you think about it from this desk?